If we want to find the Laplace transformation of sine omega t or cos omega t, we will use Euler's formula. So Euler's formula is like this: e to the power I omega t is equal to cos omega t plus I sine omega t. So this is imaginary part. So what we will do, we will find, let's say our function is ft, e to the power I omega t. So our Laplace transformation of this one ft will have which is fs, will be the Laplace transformation of e I omega t basically. So 0 to infinity e to the power minus st e I omega t dt. So this one can be written 0 to infinity integration minus s minus j omega I omega. Actually I will use j instead of I as imaginary because in electrical engineering we do that. So I will just write j omega. So yeah, so j is I dt. So this is becoming now minus here s minus j omega, and then integration e to the power minus s minus j omega t, and infinity is 0. So once we do that, it becomes minus 1 s minus j omega, and once we plug in infinity here, this one will be 0, e to the power minus infinity, because it will be 1 over e to the power infinity, so that will be 0, and then minus 1. So 0 minus 1, and we will have 1 s minus j omega. So what we do, we multiply both numerator and denominator by s plus j omega in order to get rid of the imaginary part in the denominator. So it becomes s plus j omega, and then here it is s square plus omega square minus j omega square, which is omega square. So s square minus j omega square. So this is becoming s square minus and then minus j square omega square. So this part is, this is s minus, and then s this is just j omega square, and then this is again just j square, j square, which is negative 1. So it becomes s square plus omega square. So s square plus omega square plus j omega s square plus omega square. Now if we recall, we found the Laplace transformation of e j omega t, which is equal to, should be Laplace transformation of cos omega t, because j omega t is plus j Laplace transform of sine omega t. That's how it should be, because Euler's formula tells us this thing. So from here, equating the real parts and imaginary parts, we can see that the Laplace transformation of cos omega t will be, so Laplace transformation of cos omega t will be s over s square plus omega square, and Laplace transformation of sine omega t will be, of course, omega over s square plus omega square. Just a reminder that instead of using I as the symbol of imaginary part, I have used j, but it's the same. So yeah, so this is how we find the Laplace transformation of sine omega t or cos omega t, because if we didn't do that, we would end up having the integration of multiplication of we would have a multiplication of exponential and a sinusoidal, and we had to integrate that. That would be this is actually easier to do that. this approach is better to find the Laplace transformation of the sinusoidals. So these two we usually try to remember, and there's a table actually which we try to remember. It's available everywhere in any textbook, or you can just Google it. So yeah, let's see what we do in the next video, but we will do something Laplace related hopefully. So yeah.